This is take one of the SSP panel presentation on open source technologies and scholarly communication. I'm talking about the open source project Refigure, which I co-founded with James Joseph Aiken, who goes by Joe. I'm going to start with this slide where I want to emphasize the disconnect between the research, the scholarly output cycle versus the scholarly publication cycle. As a scientist, this is what I do. I read, discover, and interpret literature. I experiment based off that. I collect data, which I then analyze and interpret. This cycle is repeated scores of times before before engagement with the publishing industry happens in the current world. Somehow then I have to convert all of my data into a story in Microsoft Word and submit it where it undergoes all sorts of human input like peer review as well as technical changes before it can be published. As when Joe and I were in our final year of graduate school, we found ourselves really frustrated with this cycle. We were essentially the producer of the goods, if you consider data and scientific information as goods, as well as the consumer of the goods. But there was a funnel effect on how much of that information was coming out. As scientists, we produce data, but apparently we found that data was not enough. We had to ignore 80% of it and massage the rest of it into a story, aka the full-length transcript. Then the story gets published. If it's paywalled, it's entirely possible that a large section of even the interested readership does not have access to it. If it is published, then you are expected to be grateful that 20% of your information made it out. And we felt that publishers as service providers were not really serving our interests in helping us get all of our information out. So we have created Refigure, which is an open source project to capture information which doesn't enter the conventional publication cycle. I want to put out my interpretations of literature. I want to put out my analysis, my analyzed data, and I want to put it out in the context of the state of the art so that I can correctly interpret the findings. I'm going to show you what we have built, give you a demo essentially. So what we built was a very light web app. It's a Chrome extension which allows readers to basically connect any published figure across the web to any other published finding. And then if they want to put their own unpublished findings in this context, they can do that. Right now, version 1 works on any papers on PMC as well as PLOS and eLife. This project was partially supported by the eLife Innovation Initiative. So let me show you what I can do with it. Let's imagine I'm reading these 3 papers on in vitro models of lymphatic transport. That's one of my things as a scientist. So there is one PMC paper here, there is one eLife paper here, and there is a PLOS paper here. As I'm reading them, I am collecting information about methods, about reproducibility, and I want to be able to view this information in the same dashboard. So we created Refigure where I can create a meta publication essentially which we call Refigure, and add figures to it as I go. So let me type my title here. I say in vitro models of lymphatic transport. Under hypothesis, if I'm actually building a meta publication about a particular hypothesis, I could type that. Here I am just saying what materials and methods are used for building in vitro models of lymphatic transport. And I can put keywords if I like, and I created it. And now I'm at PLOS, and you'll see that if I want to add a figure to this meta publication, all I have to do is click on that figure and it gets added. And you can see it captures the figure's legend, the figure's authors, the article DOI, and as well as allows the user to put down any unique features or any other thing they want to say about the figure. So I'm going to, for instance, say here that PDMS with a PD membrane. Yeah. And similarly, I can go here and find the figure that I want. Let's say I want to do this one. And again, I just click that. And again, you can see the same thing happens with PLOS. Same thing we can do on PMC. And in the end, what I generate is a meta publication which looks like this, which has my name, the keywords. I can share it on Facebook or Google. I can edit it as I see fit, which I'll show you in a minute. But basically, this allows me to view all the pertinent data in one dashboard. And this is data which would otherwise be inaccessible to the community because it's in my head. It is information about how these figures are linked. And should I want to add my own unpublished data to this, I can. And you might say, well, you can see all the information, but how you don't see the figures very well. And this is where you can see the figures crystal clear. So this is open access. And so anybody coming to the website can see these. This will be citable soon. So this adds to my my profile as a scientist. And this is completely independent of whether my final story makes it into a high impact paywall journal or not. This captures information as I think about my science on an ongoing basis. Most importantly, were you just a person who visited this paper on eLife's website, what you would see is the extension telling you that 2 figures from this paper have been linked already. This tells you that there's activity around these figures, that people are talking about them. It's in a way a better form of citation where you are immediately to go and compare the cited data with the citing data. So this is where my demo ends. And in the rest of the panel, I'll be talking about why we chose to go open source, what challenges we've faced doing so, and what advantages open source has brought us. I hope this rough mock presentation is useful to anybody who cannot make it to SSP or would like to know where we are coming from.